Hello, this is Miss Griffin. We're taking a look at Unit 4, Skill 5, where we're going to talk about this thing called CPCTC. It might sound a little weird and a little crazy, but it is kind of one of the coolest things ever as far as proofs go. You probably don't think proofs are that cool, but they're fundamental to geometry. So it says, for your essential question, what does CPCTC stand for? It's kind of a tongue twister. See how fast you can say it. CPCTC. And when can it be used? So it does stand for this thing called corresponding parts of congruent triangles are congruent. If you want to write that out every single time in a proof, that's fine. But we, as mathematicians, of course, are lazy, so we abbreviate things or we use symbols. And so here, this is represented by CPCTC, where we take the first letter of each major word in this statement and abbreviate it by each of those letters. Corresponding parts of congruent triangles are congruent. Now you do have to memorize what it stands for, but you don't have to write it out every time. Except the first couple times in a proof, I'm going to make you do it. Alright, so example 1 says, given the two triangles below, list the congruent, corresponding, or matching parts that are used to prove the triangles are congruent. And then state the triangle congruence theorem. That would be like SAS, SSS, ASA, what's another one? AAS or HL. So I'm going to start you with the first one. I'm going to use this single hash mark here on XS. And XS is congruent to this piece over here, but match up the parts. So S is obviously congruent to itself, so that means R comes first. XS is congruent to RS. Now I want you to find the other pair of corresponding parts and write it down, and find the third piece of information from this picture that you would need in order to prove the triangle's congruent. Pause the video while you do it, make sure you match up the right parts, and then check back in with me in just a second. Alright, so I found ZS is congruent to TS. You could have also said SZ is congruent to ST. And then I found these angles in the middle of my picture because I saw an X. This X, remember, gives us vertical angles. And so I said angle ZSX is congruent to angle TSR, again, matching up those corresponding parts. So now triangle blank is congruent to triangle blank by blank. So let's do triangle XSZ, the top triangle, and then find its matching parts. X goes with R, S goes with itself, and Z goes with T. By, and then we have to figure out what. So go back to your picture, mark it up with S's and A's. We have XS is a side, so it gets an S. This arc mark gets an A because it's an angle, and this gets an S, so the triangles are congruent by SAS. Now that we know our triangles are congruent, can we find any other parts that are congruent? Is there anything else in these pictures that would be congruent as well? Hopefully you're recognizing that angle Z could now be congruent to angle T, because the whole triangles are congruent. Or something like angle X is now congruent to angle R, because they match and the triangles themselves are congruent. So every single part must also be congruent, as long as they're corresponding. And then we have another pair of sides, like ZX, which should be congruent to TR. So that's something that you guys had worked on back in 4.1, was finding all the congruent corresponding parts if you knew the triangles were congruent. So we've learned how to prove triangles congruent, and now we know that if the two triangles are congruent, then corresponding sides and corresponding angles are congruent. Corresponding, again, meaning matching up. So the matching sides and the matching angles are also congruent if and only if the triangles are congruent. Or in other words, we can summarize this by saying corresponding parts, where parts, let's write this off to the side. Parts refers to sides and angles. I guess it's an and or statement. All right, corresponding parts of congruent triangles are congruent. This, again, is often referred to as CPCTC. A weird trick that I think about is that it's 3 C's separated by a PT, part-time. It has nothing to do with triangle congruence. It's just a trick to remember the order of the letters. You separate your 3 C's, boom, 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 and then you put a part-time PT in there. Again, nothing to do with triangle congruence or corresponding parts, but it's a trick. CPCTC. This is super important. Grab a highlighter, take it out, and highlight the fact that you cannot prove your triangles congruent, or use CPCTC until your triangles are congruent. So it says you must prove the triangles congruent before using CPCTC. Okay, so highlight that or outline it or something, make it stand out to you because that's super important. Otherwise, if you use CPCTC first and then to get your triangles congruent, you are wrong. All right, flip it over so we can actually see this in play in a proof. All right, so this first proof is kind of fill in the blank, just to save us some time, and the second proof we're going to actually do together. I want you to go through and mark up everything from your given, and then we'll take a look at what we need to prove. So it says AB is congruent to CD, mark it, and then put a check mark. AE is perpendicular to BD, so find AE right here and BD right here. So I'm going to put right angle boxes because I know that I definitely get right angles. And check mark. FC is perpendicular to BD, so again, right angle boxes. Check mark. And EB is congruent to FD. So this piece here is congruent to this piece here. 2 hash marks now. So if we are trying to prove that we have angle ABE and CDF, find those angles and put dots in them. ABE is here, gets a dot, and CDF is here and it gets a dot. I'm trying to prove those 2 angles congruent. So if I focus on the givens and the 2 angles that I need congruent, then it immediately tells me what 2 triangles I care about. And I'm going to try to outline them, or maybe I'll color them in, highlight them. So if you have a highlighter, let's grab that. Highlight triangle FCD. Because you can see here that we want an angle congruent within that triangle. And then we also want an angle congruent within this triangle, AEB. So I grabbed 2 different highlighters. You can grab the same color if you want, and highlight both triangles just so it stands out to you what 2 triangles we actually care about here. So now I knew that I needed these 2 triangles because the angles that I want have the dots in them within those triangles. And I have sides marked congruent already. I have angles marked congruent because of the right angles. So here I'm just going to write myself a statement that we need triangle ABE congruent to triangle CDF. And it's kind of nice when you're trying to prove angles congruent because typically the triangles you need congruent have the same exact letters. ABE for the angle, we need triangle ABE. Alright, so let's go back through our given. And based on the right angles that we marked up initially, let's talk about some of them specifically. Because I don't need all 4 of those right angles, I just need the ones within the triangles that we care about. So I go here and I see, okay, angle AEB for step 2. AEB should be congruent to angle CFD. And this is because perpendicular lines form congruent right angles. Remember, this is a definition, a phrase that you need to have memorized. So that's one set of sides, cool. Then we already, or one set of angles, whew. So we got an A here. Then we already had an S over here. And we had an S over here. But clearly, that is not okay, right? Bad word spelled backwards, not okay. But it's a right triangle. So think about your option for right triangles. That would then lead us to HL. Do we in fact have a hypotenuse, and do we in fact have a leg? So if my right angle is here, you can see me outlining it there, and I look across from it, this is not an S anymore, but it's my hypotenuse, the biggest side. And this piece here, BE, is not an S anymore, but it's a leg, because it helps form the right angle. So yes, we have HL, so yes, we can prove the triangle's congruent in step 3. Triangle ABE is congruent to triangle CDF because of HL. Then if I know that the triangles are congruent, then these angles must clearly be congruent because of that crazy long phrase that we're going to write the entire thing out for until you get it memorized. Corresponding parts of congruent triangles are congruent. Or in other words, if you want to write it in parentheses, CPCTC. Corresponding parts of congruent triangles are congruent. Example 3 has us looking at another proof, but it's not fill in the blank. This time we have to do the work ourselves. So it tells us that we want RQ. Sometimes it's nice to look ahead first. We want RQ, put a dot on it, to be congruent to NM, put a dot on it. And then, ooh, that was my phone. Then let's find out what two triangles we need congruent. Clearly there's only two triangles here, so we're just going to say need triangle RQ, and then close it up to make a P, congruent to triangle MN, close it up with the P. So I took the two letters that they gave me in the proof and made it into a triangle with a third letter, RQP and MNP. So in the given, again, we kind of looked forward first, now we're going to work backwards a little bit. They tell us that MQ and NR bisect each other. So let's stick with MQ bisecting NR. So that means I cut it in half. If I mark it, I gotta state it. NP is congruent to RP. But I also know that they cut each other in half, so I know that MQ gets cut in half to give me congruent pieces such as MP congruent to QP. And our reason is the following. Hopefully you are starting to memorize these. Segment bisector divides a segment into two congruent segments. Don't stop there, say at the midpoint. Alright, so remember we gotta get our triangles congruent first before we can use that corresponding parts of congruent triangles are congruent. So if I look at my picture again, I've got a set of sides and another set of sides, which is not enough to prove triangles congruent. So we have to find something else in this picture. Remember, the only things you're allowed to assume in a picture are vertical angles or reflexive. And I am seeing vertical angles because I see an X here. So I'm going to put arc marks in them. And I'm going to call them 1 and 2. Because remember, we're allowed to do that as long as we mark it up in the picture. So I know that angle 1 is congruent to angle 2. And this is because vertical angles, if I stop there, I'm wrong. So I have to keep going. Vertical angles are congruent. Alright, so now that gives me a pair of angles. So I have 3 parts. I have 2 S's and an A. So I have to decide what order do they go in and how are they proving my triangles congruent. So step 4 is that triangle RQP is congruent to triangle MNP I guess I should be saying, sorry, N, can I erase this? Triangle N, M, P, so that I match up the right parts. So I'm going to adjust that up here, N, M, P. Sorry about that. You know, we're always telling you guys to match up the right parts, so I got to do the same. R matches with N, Q matches with M, and P, of course, with itself. All right, so back to proving the triangle's congruent. We have S, A, S to prove those two triangles congruent, because the angle is between my two sets of sides. So then last and final step, because I know that the triangles are congruent, I now know that RQ is congruent to NM. And this is because of that crazy long reason. These are corresponding sides, so we're going to say corresponding parts of congruent triangles are congruent. And again, see if you can write it out in parentheses with the 5 letters in the correct order. If you shorten it to the 5 letters and you get it wrong, not the correct order, you have to lose credit. And so that's super unfortunate. Make sure that when you are making your flashcards or when you're memorizing this stuff that you get it written down in the correct order and memorize it correctly. All right. Hopefully you enjoyed CPCTC. It's the coolest thing ever, right? I'm sure that you already agree with me. You've agreed with me from the start. Anyways, good luck. Let us know if we can help you. Remember that you can always rewind the video if you need to. See ya.